Welcome to the DIY Honda Garage channel. DTC P0327 refers to a low voltage detected in the knock sensor circuit of the Honda Civic models from 2011 to 2015. The knock sensor is an important component that helps the engine control module, ECM, detect unwanted engine vibrations or knocking. Its role is crucial for adjusting the timing and maintaining optimal engine performance. The sensor is typically located on the engine block, attached near the cylinders, where it can effectively monitor the engine vibrations. When the DTC is triggered, it could indicate an issue with the knock sensor itself or other related components. It's important to address this error promptly to ensure engine longevity and performance. The knock sensor's primary function is to monitor engine vibrations and detect knocking or pinging, a phenomenon detrimental to engine health. When the engine experiences knocking, the sensor sends a voltage signal to the ECM, which adjusts engine timing to protect the engine. The ECM, or engine control module, processes this input to optimize engine performance. The knock sensor is usually located on the engine block, often near the cylinder head, making it easily accessible, yet exposed to engine heat. When low voltage is detected in the knock sensor circuit, it can affect engine performance and trigger DTC P0327. Understanding this error necessitates familiarity with the sensor's role, its connection to the ECM, and its physical location. Several factors can lead to DTC P0327 being triggered. Firstly, a faulty knock sensor could be the primary culprit. If the sensor is damaged or malfunctioning, it will not be able to send accurate voltage signals to the ECM. Secondly, wiring issues, such as shorts or cuts in the wire leading to the knock sensor, may prevent effective communication. Thirdly, loose connections at either the knock sensor or the ECM can also result in voltage irregularities, leading to the error code. It is crucial to systematically evaluate these potential causes during troubleshooting to resolve the issue effectively. Each component's integrity must be assessed to ensure reliable engine performance. When DTC P0327 appears, a variety of symptoms may surface. One of the most noticeable symptoms is degraded engine performance, as the ECM may not be able to adjust timing effectively without proper input from the knock sensor. Additionally, you may notice an increase in fuel consumption as the engine tries to compensate for inefficient operation. The check engine light on the dashboard will also illuminate, alerting the driver that there is an issue that needs to be addressed. Under certain conditions, the engine may even experience knocking, leading to further damage if not corrected. Recognizing these symptoms early can significantly mitigate potential engine problems and costs. The first step in troubleshooting DTC P0327 involves verifying the issue. Begin by turning the ignition switch to on to ensure the vehicle's electrical systems are active. After this, utilize the Honda Diagnostic System HDS to clear the DTC. Following this action, set the ignition switch to lock, 0, and then back to on once again. At this stage, recheck for any pending or confirmed DTCs using the HDS. If DTC P0327 is still indicated, it confirms that the failure has duplicated and you should proceed to the next step. However, if it does not appear, this may suggest an intermittent issue, warranting further investigation into potential poor connections or loose terminals at the knock sensor or ECM. In the second troubleshooting step, you will focus on determining the possible failure area. Start by turning the ignition switch to lock, 0. Next, disconnect the knock sensor by removing the 2P connector. Once disconnected, turn the ignition switch to on, I, again. At this point, utilize the HDS to check for any pending or confirmed DTCs. Specifically, you need to see if DTC P0328 is indicated. If DTC P0328 is present, this signifies a problem with the knock sensor itself, and replacement is necessary. However, if it does not appear, you will move on to the next investigative step to further assess the circuit. In this third troubleshooting step, your objective is to check for potential shorts in the wiring associated with the knock sensor. First, turn the ignition switch to lock 0 again. Then, use HDS to jump the SCS line. Disconnect the ECM connector C49P to ensure a clean circuit for testing. You'll want to check for continuity between the two test points, specifically between the knock sensor 2P connector 1, black wire, and the KSGND line. The test condition requires the ignition to be off with the knock sensor 2P connector and ECM connector both disconnected. Finding continuity would indicate a short in the knock wire, requiring repair. If there is no continuity, you will proceed to further isolate the issue. During the fourth troubleshooting step, the focus is on the knock line continuity. Ensure the ignition switch is in the lock 0 position and keep the knock sensor 2P connector disconnected while you also have the ECM connector C49P disconnected. You will need to test for continuity between the knock line, white wire from the sensor, and body ground. If continuity is detected, this indicates there is an unintended connection or a short in the knock wire between the ECM and the knock sensor that needs to be repaired. Alternatively, if there is no continuity, the knock wire is functioning as expected, leading you to check whether the ECM has the latest software. If it does not, an update is necessary, or a substitution with a known good ECM may become the next actionable step. After completing the necessary repairs related to DTC P0327, it is essential to perform a final verification to ensure that the issue has been resolved. Begin by turning the ignition switch to lock 0 and then reconnecting all previously disconnected connectors. Once all connections are secured, turn the ignition switch to on and use the HDS to reset the ECM. Following this, the ECM idle learn procedure should be conducted, which assists the ECM in adapting to any changes in the engine's operation following the repairs. Finally, check for any pending or confirmed DTCs using the HDS. If DTC P0327 appears, inspect for any poor connections or loose terminals again. If the ECM was updated, consider substituting it with a known good unit for further verification if necessary. To prevent the recurrence of DTC P0327, regular preventive maintenance is highly recommended. Start with routine inspections of the knock sensor and associated wiring connections to ensure they remain secure and free from damage. Over time, exposure to heat and vibration can lead to wear on these components, so being proactive can mitigate future problems. Additionally, it's wise to maintain the efficiency of the knock sensor. Consider cleaning its area or monitoring engine performance closely. Regularly having the ECN software updated can also help ensure that the system operates under optimal parameters. Overall, proactive maintenance can extend the life of the vehicle and help avoid costly repairs down the road. In conclusion, understanding DTC P0327 and the function of the knock sensor is crucial for maintaining the Honda Civics performance from 2011 to 2015. Following the troubleshooting steps methodically allows technicians to identify the root cause effectively, whether it be the knock sensor itself, wiring issues, or problems at the ECM. Addressing the error promptly ensures the engine runs smoothly and efficiently, helps save on fuel, and prevents further damage. Preventive maintenance is equally important. By regularly inspecting the knock sensor and its connections, you can significantly reduce the likelihood of encountering this DTC in the future. Ultimately, being knowledgeable about the components and employing systematic troubleshooting will lead to successful resolution and enhanced vehicle dependability. Please like and subscribe to the channel. See you next time.